Okay, in this lecture we're going to look at how to utilize a t-statistic to calculate a hypothesis. It's virtually identical to the z, you just have to know how to interpret a t, okay? So when testing a hypothesis, the t-score is calculated just like the z-score, except you notice right here is the t, and right here this is the standard deviation of the sample. The standard deviation of the sample. So you use the t-score or the t-distribution when the standard deviation of the population is unknown. Okay, it's a continuous distribution. It's bell-shaped and symmetrical. There's a family of t-distributions. It's flatter and more spread out. This is the exact same t-distribution as what we were dealing with in chapters 9. Chapters 9, yep. So here's an example. The McFarland Insurance Company Claims Department reports that the mean cost to process a claim is $60. Okay, so that is mu equals 60. Okay, an industry comparison shows this amount to be larger than most other insurance companies. So the company instituted cost-cutting measures to evaluate the cost-cutting measure. A random sample was taken of 26 claims processed last month, and the cost to process each claim was recorded. So down here are the cost of every single claim. Okay, at the 0.01 significance level, is it reasonable to conclude the mean cost to process a claim is now less than 60,000. So this is is this a directional or is this a one-tailed or two-tailed test? And the way that we can determine whether or not this is a one-tailed or two-tailed test, how can we determine? Okay, we want to know, is it now less than? If we want to know if it's less than, then it is a one-tailed test. So the alternative hypothesis is that the new point estimate of the population is less than $60. Okay, the null hypothesis is that the new point estimate of the population, point estimate mean of the population, is greater than or equal to $60. Okay, let's go at the next slide and see what we find out. Okay, first of all, if you were to add up all of these together and divide it by the total number of observations, you would get 56.423. Okay, that is the new mean of the new mean of all of the cost to process claims. So the first thing that we did is we stated the hypothesis and the alternative hypothesis. So we've got the alternative hypothesis and the null hypothesis right here. Step 2, we're selecting the level of significance. We're going to be using 0.01 for the level of significance. Okay, notice 0.01 right here on the t-table. Okay, this right here is for a one-tailed test. Okay, if we were doing a two-tailed test, the 0.01 would be right here. See, level of significance for a two-tailed test, 0.01 for a two-tailed test, 0.01 for a one-tailed test. Okay, so we select a test statistic. We're going to utilize t, because we do not know the population standard deviation. Because of that, we need to determine the degrees of freedom. The degrees of freedom, do you all remember how to determine the degrees of freedom? The degrees of freedom is n minus 1. So looking right here, let's see, 1, 2, 3, 4, 5, 6 times 4 plus 2. 6 times 4 is 24, 25, 26. So we've got a total of 25 is our degrees of freedom because it's 26 minus 1. Let's see. 26 minus 1 is our degrees of freedom. So on the t-table, we find degrees of freedom 25, and we go over to 0.01, which is 2.485 is the level of significance or the critical value utilizing the t table. Okay, the critical value. So in other words, if the t-value that we calculate is more extreme or below the critical value, the t-crit value of negative 2.485, then we reject the null hypothesis. But if it's less than that or less extreme than that, then we fail to reject the null hypothesis. So we do 56.423 minus 60. So we formulate the decision rule. We're rejecting the null hypothesis if t is less than negative 2.485. Then we take a sample to make the decision. Take a sample and make a decision. And we do not reject the null hypothesis. And the reason why is because we calculate t-crit, or sorry, t-calc. That's the calculated t-score. T-calc equals negative 1.82. So negative 1.82, is this less extreme or more extreme than t-crit of, which this is t-crit. When I say t-crit, I mean the t-critical value. When I say t-calc, I mean the t-calculated value. So negative 2.485 is less extreme, or sorry, negative 1.818 is less extreme than negative 2.485. So therefore, I fail to reject the null hypothesis. And then I conclude that the cost-cutting measures were not effective enough to make that claim. So that is using a t-score. So just be very familiar with how to interpret the degrees of freedom. Also make sure that you know level of significance for one-tailed versus level of significance for two-tailed. Okay? Let's see here.